Let's get started. The first question is about graphing an exponential function of the type dk. We have 1/2 to the power x, and let's build a small table. Plug in 0, we have 1/2 to the power 0, which is 1. And anything raised to the power 0 is 1, so we have 0, 1. That's this point right here. When we plug in 1 for x, we have 1/2 to the power 1, and that's 1/2 for the y value, so we have 1.5. That's right there. Now -1. 1/2 to the power -1 equals 1 to the power -1 over 2 to the power -1, which is 2 to the power 1 positive 1 over 1 to the positive 1, which is 2. So -1 will give me 2. The reason why anything raised to the power -m becomes 1 over a to the power positive m. So -1 is going to give me 2. When x equals 2, that's 1/2 to the power 2, which is 1/2 times 1/2, and that's 1/4. So x equals 2, 1/4 for y. That's somewhere right here. Finally, -2, 1 over 2 to the power -2 will be flipped with this right here, and it's going to be 2 to the power -2 down here. That's going to go up to 2 to the positive 2, which is 4. So -2 will give me 4. -2 will give us 4. And that is called an exponential decay, and the graph should look like this. So the domain is all real numbers. The range is the y values above 0. So from 0 to infinity. The y-intercept is right here, and that is 0, 1. This is the y-intercept. The asymptote, we only have a horizontal asymptote. We don't have a vertical asymptote. It keeps going up. So we have a horizontal asymptote, which is the x-axis, and that is y equal 0. Or you could write the x-axis. The end behavior. As x goes all the way to the right, the graph goes down to the x-axis, so y approaches 0. As x approaches -infinity, going all the way to the left, the graph will take you up, all the way up. We say positive infinity. Done with the first problem. The second problem, we're graphing an exponential function of the type when b is greater than 1, that's exponential growth, but reflected about the x-axis because we have a negative sign right here. So let's take some time and plug in some numbers. Anything raised to the power 0 is 1, and anything raised to the power -m is 1 over a to the m for this one right here and this one right here. So we have -2 to the power 0 when x equals 0. That's -1 because 2 to the power 0 is 1. So we have 0, -1. That's why the grid is taking you down. You don't need the top portion. Plug in 1. That's negative outside. X equals 1. 2 to the power 1 is 2, so it's -2. The minus does not cancel. So we have 1 and -2. 1 will take you down to negative 2. When you plug in negative 1, that will be a reciprocal, will flip down. The negative outside is still outside, 1 over 2 to the power 1, which is negative half. So negative 1 will give you negative half. That's somewhere here, negative 1 for x and negative half for y. Plug in 2, I have 2 to the second with a negative outside. That's negative 4. So 2 for x, negative 4 for y. 2 for x, negative 4 for y. And finally, x equals negative 2. That will be 1 over 2 to the power positive 2. And that's 1 over 4 with a negative sign. So negative 2 will give you negative 1/4. Negative 2 will give you negative 1/4. To graph it, we're going to go just like this. And now we're ready to answer what we have to fill in right here. The domain is still all real numbers. The range, everything is below the x-axis, so we say y less than 0, or differently, all the way from negative infinity down to 0, not including 0. The y-intercept is right here. That is 0, negative 1. The asymptote, we have a horizontal asymptote as the x-axis, or y equal 0. The end behavior, as x approaches infinity all the way to the right, the graph takes you all the way down. We say y goes to negative infinity. As x approaches negative infinity going all the way to the left, y approaches 0 from the bottom side. We just say y approaches 0. Done with question number 2. Number 3, solve the following. Notice that 4 equals 2 to the second and 8 equals 2 to the third. So we have 2 to the second and we have 2 to the third instead of 8. Everything here is raised to the power 2x plus 1. And here everything is raised to the power 3x minus 1. 3x minus 1. We have a formula that says a to the power m all raised to the power n equals a to the power m times n. In this case, this is m and this is n, so we need to multiply them. That becomes 2 to the power 2 multiplied by 2x plus 1, and this becomes 2 to the power 3 multiplied by 3x minus 1, 2 to the power 4x using the distributive property, plus 2 equals 2 to the power, same idea, 3 times 3x, which is 9x, 3 times minus 1 is minus 3. Another formula says a to the power m equals a to the power n if and only if m equals n. We're going to apply it. This implies that 4x plus 2 equals 9x minus 3. We'll have x's on one side, so let's subtract 4x from both sides. And now I have on the left 2 equals, and on the right side 9x minus 4x, which is 5x minus 3. Add 3 to both sides. This cancels, and that is the plan, to leave x by itself. 5x equals 5, divide by 5, divide by 5, and finally x equals 1. That should do it. Next problem. Solve the following. We need to have the same base, just like before. We need to use the formula that says a equals, or b equals, b to the power t equals b to the power s. That is equivalent, or if and only if, t equals s. So to have the same base, I need to think about 25 as 5 to the second. So the problem becomes 5 to the power 2x equals 5 to the second instead of 25, all raised to the power x plus 5. The other formula that I'm going to apply says a to the power m to the power n equals a to the power m times n. So we have 5 to the power 2x equals 5 to the power 2 multiplied by x plus 5, meaning 5 to the power 2x equals 5 to the power 2x plus 2 times 5, which is 10. Now let's apply this formula. This implies that 2x equals 2x plus 10. Subtract 2x from both sides, and left hand side is 0, right hand side is 0 plus 10, which is 10, but 0 does not equal to 10, so we say no solution. So the answer is no solution. Find the sum of the geometric series to the nearest 10,000. The formula is the sum of n terms in a geometric series is equal to a sub 1, or the first term, that's a sub 1, multiplied by 1 minus the common ratio, r to the power n, all over 1 minus r. So the sum of 12 terms, because n is 12, will be, the first term is 4, 1 minus r is 1/2 to the power 12, all over minus 1r, which is 1 minus half. And 1 minus half is half, so that is equal to 4 times 1 minus 1/2, or you could write 0.5, it's exact 0.5 to the power 12, all over 1 minus half, that's half, or 0.5. Just want to write less fractions, so I could use the calculator. Or you could simplify 4 divided by half, which is 8. But let's just finish it this way. So I have the following. Four multiplied by 1 minus half, or 0.5, to the power 12, that's my numerator, equal, all divided by the denominator, which is half. So that's the answer. Since we need to round to 4 digits, that's called 10,000. So the answer is about 7.9980. That's tens, hundreds, thousands, 10,000s. Since 4 is less than 5, we just drop these digits. Number 6. Find a sub n for each geometric sequence. For the following geometric sequence, I only have one. So we have a sub n equals a sub 1 multiplied by r to the power n minus 1. In this case, it's a sub 8. That's the 8th term. The first term, a sub 1, is 5. So I'm going to write 5 multiplied by r, which is 2, the common ratio, to the power n minus 1. That's 8 minus 1. So it's a 5 multiplied by 2 to the power 7. One way to do this problem is you could do the following. You could say 2 to the power 7 equal, multiply that by 5, and the answer is 640. That should do it for number 6. Number 7. Caesar invested $5,000 in an account that grows continuously. So continuously is something different than compounded, like the second problem after this one. That is continuously, something to be careful about. So we have $5,000 and 4.3% rate, 7 years. Part A says write the function that represents the situation. So we have y equal a times e to the power rt, and r has to be in decimal form. So we have a, the initial amount, 5,000, multiplied by e to the power r is 0.043, because 4.3% is 4.3 over 100, and the decimal gets moved to the left 2 places, which is 0.043. It was here, now move to the left 2 places. So we need to write 0.043 multiplied by t, which is 7 years. That is t. Another way to do this problem, instead of typing the whole thing, I would say e to the power, open parentheses, multiply 0.043 times 7. That will give me this factor, and when you finish, multiply it by 5,000. 1, 2, 3, and it's about, since it's money, we need to round to 2 digits. It's about 6756.05, not 4. 6 is higher than 5, or 5 and greater than 5. That means we need to drop it and change the 4 to 5. $6,756.05. That is number 7. Now, number 8. Nancy deposits $5,300 into a savings account that pays 6.2% annual interest compounded monthly. That's different than continuously, and we need also to do that for 5 years. The formula is y equal P for the principal or the initial amount multiplied by 1 plus R as a decimal over n to the power nt. R is 6.2%, which is 0.062 as a decimal. Going back to the problem, we have 5,300 multiplied by 1 plus 0.062 divided by n, and monthly means n equals 12. So we have 12 here, all to the power 12 for n and 5 for t. T equals 5. To reduce typing, we could change 12 times 5 to 60, because that is 60. And you could type the whole thing, but a good way to do it is like order operations. I'm gonna say 0.062 divided by 12. That will give me this amount. We're gonna add 1 to it. So that's the inside part. Raised to the power 60. Then after that, I need to multiply it by 5300. And that's what we have. Of course, that's money, so we need to round to 2 digits. So we say about $7,220.39. That becomes 39 cents. 8 is too high to ignore. We drop these digits and we make this 39. Done with number 8. Number 9. Solve the following. So we have 7 to the power 2x equals 5. So the way to do it, to bring the 2x down, we need to use the natural log or logarithms. So we're going to apply len to both sides. That will bring the 2x up front. The formula says len a to the power x is the same thing as x len a. It's like you could bring the x to the front. So in this case, we're going to bring this to the front. So the problem becomes 2x in the front times len 7 equals len 5. We're going to divide both sides by len 7. And let's do 2 steps in one and get rid of the 2 at the same time. As you could see, 2 cancels and len 7 cancels, and now we have x by itself. So the left hand side is x, the right hand side is len 5, all divided by 2 len 7. Let's reach out for the calculator, and here's what I'm going to do. Open parenthesis, len 5 for the top, that's my numerator, divided by open parenthesis for the denominator. Inside I'm going to write 2 len 7, close the 7 and close the denominator, and I have 0.41354 37377. We need to round to 10 thousandths, so that is approximate to 0.4135. Tenths, hundreds, thousandths, 10 thousandths. 4 is less than 5, so we just drop it. Number 10. Write the following in logarithmic form. This is a quick one. So I have log. The base is 3, goes right there. The exponent is 5. 3 to the power 5 equals the argument, which is 243. Done. Number 11. Evaluate the following. Log 66 over log 4. This is called the change of base formula. The formula says log A base B will equal log A base 10 over log B base 10. So the problem is now log 66, I don't have to write base 10 if it's common log, over log 4. Again, so we have the numerator is log 66, that's my numerator, divide by the denominator, which is log 4, close the 4, close the denominator, and it's about 3.022, and 9 will change the 1 to 2, another 2. Usually in logs we approximate to 10,000s. Number 12. Solve the following. Log x base 64 equals 2/3. We could rewrite it in exponential form. So we have 64 to the power 2/3 equals x. We have a to the power m to the power n equals a to the power mn. So for this problem, the left hand side is like 64 to the power 1/3 multiplied by 2 over 1. That's my m, that's my n in this case. So we're going to break it down to this format. We're going to take it back from this form to this form. Equals x, left hand side is 64 to the power 1/3 to the power 2. 2 times 1/3 is 2/3, takes you back. 64 to the power 1/3, anything raised to the power 1/3, it means the cubic root of x. So we have the cubic root of 64 raised to the second equals x. Cubic root means to the power 1/3, which is 4. 64 to the power 1/3, that's the cubic root, which is 4. So inside it's 4, we still have the 2. 4 to the second is 16, and that should do it. So x equals 16. Number 13, write the following or solve the following. One of the formulas says that log A plus log B becomes 1 log with the product of A and B. So we're going to apply to the left. The second formula will say log A equals log B implies A equals B. Same base, or if and only if. So that's two formulas. That's one, and that's the other one. Let's use the first one on the left side. So the left hand side becomes 1 log. Of course, this time it's base 3, it's not base 10. Same base. 2 times 5. So we multiply them. A times B, 2 times 5. Right hand side, let's just keep it for now. 2x plus 4. Now we're going to apply the second property. So when log a equals log b, we could drop the logs since it's the same base and go to the arguments, which is a equals b. Log 3, same base. That's my a, that's my b in this case. That implies that 2 times 5 equals 2x plus 4. 10 equals 2x plus 4. Subtract 4 from both sides. So I have 2x equals 6. Divide by 2 on both sides. X equals 3, and that is our answer. X equals 3. Number 14, I have two parts or two examples for number 14. You'll see the reason in just a second. Solving the following, we have ln 5x minus 4 equals ln x. If I subtract ln x from both sides to move the ln's to one side, it's going to show up here with minus. And if I add 4 to both sides to move the 4 away, it's going to show up 4 on the other side. So sometimes we say, like, let's move things around. Moving this to the left will change it to minus. Moving the minus 4 to the right will change it to plus. So I have ln 5x minus ln x equals 4. One of the properties says that log a minus log b, of course, same base. That would be 1 log with a over b. So the left hand side becomes 1 ln with 5x divided by x. That's my a, that's my b, equals 4. But x cancels, so we have ln 5 equals 4, but that is not true, because ln 5 is the following. Here's ln 5 is about 1.6094. And this is like saying that 1.6094 equals 4, and that's not true. So no solution. Second problem, or second type. Solve the following. We're going to move the ln 2 to the left and move the 4 to the right side. This time I have 2 here, not x. So we have ln 6x minus ln 2 equals positive 4. We're going to apply the same formula right here. So that's 1 ln a over b. That's my 6x over b, which is 2, equals 4. 6 and 2 simplifies to 3. Ln 3x equals 4. We're going to raise both sides with the base e or rewrite it in exponential form. So I have e to the 4 equals 3x. Divide by 3, divide by 3. So x equals e to the 4 over 3. Moving to the right side, I have x equals e to the 4 over 3, which is about here's e to the 4, enter, divided by 3, approximate to 18.1994. Because 8 is too high, we need to round the 3 and make it 4. Or add 1 to the 3 and make it 4. That's called rounding to 10,000s. Number 15. Solve the following. E to the 3x plus 4 outside equals 12. Subtract 4 from both sides. So I have e to the 3x equals 8. Let's rewrite it again and apply len to both sides. Len and len. The reason why, len is the inverse function of e, so they will cancel, or you could bring the 3x to the front, and that's going to be 3x times len e, but len e is 1. Any way you do it, these will cancel. Left hand side is just 3x. Divide both sides by 3. X equals len 8, all divided by 3. To round to 10,000s, we need a calculator. And here we go. So we have len 8 divided by 3. So the answer is about 0.6931. 4 is lower than 5, so we just drop these digits. Number 16. Solve 7 equals len x minus 5 and round to the nearest 10,000s. So I have 7 equals len x minus 5. The way to do it, we could raise both sides with the base e, 7, and len x minus 5. This will cancel, or you could think about this as base e and e to the 7 equals, which is the same thing as we have. So the problem becomes e to the 7. One more time, this cancels, and we have x minus 5 by itself. We're gonna add 5 to both sides. Left hand side is e to the 7 plus 5 being added to it equals x. So now x equal e to the 7 plus 5. Since we need to evaluate that, we use a calculator. And now we have the following. We have e to the 7. We could go out of that plus 5, or find e to the 7 by itself, then add 5. Let me show you how to do it. That's e to the 7. You finish it, then you add 5. Same answer. So approximate to 1101.6332. This 5 will make the 1 2. Last problem. Number 17. Given sine a equals 20 over 29, and that is the opposite, the ratio of the opposite to the hypotenuse. And since this is small a, that will be capital A, the angle A, and it goes this way. This is small c, the hypotenuse, and the only left is angle B, which means this is side B. Pythagorean theorem says a square plus b square equals c square. But a is the opposite of angle A, that is 20, so that is 20. And the hypotenuse is 29, which is c, that is 29. So we have 20 square plus b square equals 29 square. 20 times 20 is 400 plus b square equals 29 squared, which is 841. That's 841. We need to subtract 400 from both sides to solve for b. And b squared by itself, I still have the 841. Subtract 400, 441. Now, if b squared equals 441, b should be the square root of 441. 441. We don't need to write plus minus. Usually we write plus minus. And let's take the square root of 441. Square root of 441. The answer is 21. B is exactly 21. So that is 21. Now sine was given to me. So let's write it down. 20 over 29 for sine A. 20 over 29. Cosine A is defined to be the ratio of the adjacent to the hypotenuse. That is my adjacent, 21, to the hypotenuse, which is 29. Tan is opposite over, standing right here of course, opposite over adjacent. That is 20 over 21. Cosecant is the hypotenuse over the opposite. But I don't want to say all these ones. I don't need to because I have them aligned. Cosecant is the reciprocal of sine. Secant is the reciprocal of cosine. And cotan is the reciprocal of tan. So if this is 20 over 29, cosecant is 29 over 20. Secant is going to be 29 over 21. And cotan is the reciprocal of tan, which is 21 over 20. Meaning cotan is not the opposite over the adjacent, it's the adjacent over the opposite. That's your adjacent, standing right here. And that's your opposite, adjacent over opposite, 21 over 20. And that should do it. 17 problems.
Thank you for watching. If you like this video, hit the like button and subscribe, and I'll see you next time. Thank you.